Climate tipping points are a growing concern for both scientists and the public, but what are they? How might they affect us? And can we predict them? The Earth's climate is changing, with humanity's carbon dioxide emissions pushing up average temperatures through the greenhouse effect. So far, temperatures have gone up steadily along with CO2 emissions, but future warming may not be gradual. Passing a tipping point can cause rapid change. You can think of tipping points like a seesaw. Pushing the ball up the ramp is like human CO2 emissions pushing temperatures up. Before the pivot is reached, the ball can come back down, but once you pass the tipping point, the ball carries on and speeds up without any further pushing. Eventually, the ball comes to rest in a new steady state, and it is more difficult for it to return. For the climate, this would be the Earth passing a climate tipping point and reaching a new normal as a hotter planet. Tipping points can happen when positive feedback loops kick in. One of these may now be happening with Arctic summer sea ice. Sea ice reflects more energy from the sun back into space than darker open sea, and this keeps the Arctic cooler. But global warming is melting the summer sea ice, which is exposing more open sea, reducing the solar energy reflected by ice, and amplifying local warming. Beyond a future tipping point, the summer sea ice may rapidly retreat and the whole Arctic will warm up much more than the rest of the world. This feedback loop has already started in the Arctic, and there are many other potential feedback loops linked to climate change. Other possible tipping points that may soon be crossed include ice sheet collapse in West Antarctica, which would raise sea levels, and methane release from melting Arctic permafrost, which as a strong greenhouse gas would amplify global warming. We want to be able to predict tipping points like these in advance, so that we can either avoid triggering them or prepare for the consequences if that's too late. Scientists are using models and records of ancient climate change to find when tipping points may have happened in the past. One example is when ice sheets rapidly melted at the end of the Ice Age glacial periods, despite having been stable for tens of thousands of years. Before these ancient tipping points, subtle changes like increased variability can often be seen, which are known as early warning signals. These are a bit like when a spinning top slows down. It starts to wobble more and more before it finally tips over. We can monitor the climate for wobbles like these using advanced mathematical techniques and then compare them to records of ancient climate tipping points. To find out more about climate tipping points, visit www.climatetippingpoints.info, follow Climate Tip Point on Twitter, or find climatetippingpoints.info on Facebook. This outreach was funded by the Recover Network, which supports research on changes of variability and environmental risk.